Decision tree and random forest classifier. So once you are done with the extraction of subsamples from the data set, create decision tree based on the selected features within the subsample. The predictions from the subsamples are aggregated to a decision tree to make a final combined prediction. These aggregations are often done on the basis of predictions made or the likelihood of the predictions made by the bootstrapped individual models. Now, when you have multiple individual decision trees, let's understand how a combination of individual decision trees can lead to a random forest classifier. Combining predictions from multiple models into ensembles works better if the predictions from the submodels are uncorrelated or at best weakly correlated. Random forest changes the algorithm for the way that the subtrees are learned so that the resulting predictions from all of the subtrees have less correlation. This is how random forest classifier provides a better accuracy with respect to decision tree. Performance measures. Confusion matrix. Confusion matrix is a performance measurement for machine learning classification where output can be two or more classes. The table given 4 different combinations of predicted and actual values. It is extremely useful for measuring recall, specificity, accuracy, precision, and most importantly, AUC-ROC curve. True positive. Interpretation: you predicted positive and it's true. You predicted that India will win the match and India won. True negative. Interpretation: you predicted negative and it is true. You predicted that India will not win the match, and India did not. False positive, type 1 error. Interpretation: you predicted positive and it's false. You predicted that India will not win the match, but India did. False negative, type 2 error. Interpretation: you predicted negative and it's false. You predicted that India will win the match, but India didn't. In order to understand the confusion matrix better, let's first understand what accuracy metric is. Classification rate or accuracy is the ratio of true positives and true negatives to the sum of true positives, true negatives, and false positives. Or you can say accuracy, ACC, is calculated as the ratio of number of all correct predictions with the total number of data sets. The best accuracy is 1.0, whereas the worst is 0.0. So what are the limitations of accuracy? There are problems with accuracy as it assumes equal cost for both kinds of errors. A 99% accuracy can be excellent, good, average, or poor, depending on the problem. Consider a 2-class problem. Number of class 0 examples is 9990. Number of class 1 examples is 10. If the model predicts every example to be class 0, accuracy is 9990 over 10,000 equals 99.9%. Hence, accuracy is misleading because the model does not detect any class 1 example. Performance measures, cost matrix. Let's look at how cost matrix differs from the confusion matrix. Cost matrix is similar to the confusion matrix, except that it calculates the cost of wrong prediction or right prediction. The weighted accuracy corresponds to the correctly detected samples divided by the total number of samples. It thus solves the problems associated with the normal accuracy matrix. Let's compute the cost of classification of a model. Model M1, M2 are 2 models, both of which have correct predictions and wrong predictions. If we compare both the models, and if we check their accuracy, then accuracy for model M2 is higher than model M1, but the cost for model M2 is higher than model M1. So it depends on what kind of problem statement you are facing. If the focus is on accuracy, then go with the model M2. You will need to compromise on cost. However, if the focus is on cost, then we will go with the model M1. You will need to compromise on accuracy. Let's understand how cost and accuracy are related to each other. Accuracy is proportional to cost. If class I2 J1 is yes, no, or class I1 J2 is no, yes, then value is Q. When class I1 J1 is yes, yes, or class I2 J2 is no, no, then value is P. The sum of the total is N equals A plus B plus C plus D. That is the sum of all possible predictive capability of a model. Accuracy equals the set of A plus D divided by N, which is equal to the sum of the true positive and true negative divided by the total predictive value. So when you simplify the given cost equation, it will give you the equation where cost will be directly proportional to the accuracy of the model. Demo, horse survival. Problem statement. Predict the survival of a horse based on various observed medical conditions. Load the data from the horse.csv and check whether it contains any missing values. The dataset contains many categorical features. Replace them with label encoding.